everyone, welcome to the first video on significant figures. This is the first of 4 videos to try to break it up so that you can better understand each component of it. The first thing we're going to look at is significant figures and how to measure an estimated digit. So this should also help you with lab. First we need to determine or decipher the difference between an exact number and an inexact number. Okay, so let me pull this up really quick. Alright, so an exact number is a result of counting objects. It could be part of a definition, okay, if it's defined as a set number. Okay, I have 10 fingers and 10 toes. There's no in between there. Okay, for most people, I guess. And also for unit factors. So hopefully you've watched some previous videos or gotten from the book what a unit factor is, and I wanted to show them just in case, but you can find these anywhere. But these are unit factors, so these are also called conversion factors. Okay, these are exact numbers, and that's really important to remember for later when we start using these and converting from one unit to another. Okay, and so 1 foot, there's 12 inches in it. That is an exact number. Okay, and some of these numbers will vary depending on, not much, but depending on the book or the website that you go to. Some might have, for instance, I think it's the pound, like if you look over here, there's 2.20 pounds in 1 kilogram. Some will put 2.205. Okay, they'll use more digits. Okay, but in general, whichever one you're using, okay, these are exact numbers. Okay, so that's going to be important. All right, inexact numbers are things that you measure. Okay, so these are observations that contain some uncertainty. So how I view the water in a graduated cylinder might be a tiny bit different than what your friend or your other classmate might view. Okay, so there's always just a small room for error, and so what we have to do is we have to measure to one estimated digit. Okay, and so I'm going to show you what that really means. So you'll hear that a lot, but we need to see exactly what that means. Okay, so if we look at the picture on the left, we have a ruler. Okay, what it means to measure to one estimated digit is to look first at your device or your instrument. So here our instrument is a ruler. I know that's real sophisticated and everything, but that's what we're going to look at first. Okay, and so you're going to look at how it's calibrated. That's the first thing you need to do with any instrument or any instrumentation that you're using. Okay, and so I see, okay, it's definitely this black is our paper, for example, or our object. Okay, that black object is definitely between 13 and 14. Okay, but then I have to look at the little tick marks, the little calibration points, and see what do those stand for. So if I look at it, it looks like if between I have 13 and 14, it looks like I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little marks. Okay, so that means that each one of those is 0.1. So 13.1, 0.2, 0.3, 0.4, 0.5. Okay, you get the point. All right, so then I go and I find, okay, I definitely am for sure, based on this calibration point here, that, whoops, okay, that this black object is in between those 2 points. Okay, so that's 13.1 to 3. Okay, so I'm going to write that down. 13.3. We're going to pretend this is in inches, we're going to say. Okay, so that's going to be our last number. Okay, but this number alone, these 3 numbers, these are significant digits, and we'll learn more about what that means later. Okay, these 3, okay, this is not enough information. Okay, I have not estimated a digit. Okay, the 13 comes from here, and then I know for sure that that object is between 0.3 and 0.4. Okay, my estimated digit, and this may be different. So when you look at this, okay, and you may want to, I guess I could have tried to zoom in on it. Let me see if I can do that. Okay, all right. So if I look at that and I look at that black mark, okay, or my black object, I'm going to call that 13.3, and I think it's halfway in between, so I'm going to call it 13.35. Okay? You may look at that and say, I think that's 13.36. Okay? Someone else may think 3.4. Okay? That is the digit that is, there's room for error. Okay? That's an estimated digit. Okay? So when you record and you measure an object or a substance, okay, then you're going to look at the calibration and look at how it's broken up, and then you always estimate one digit. So you're looking at where does it fall in between two calibration points. Okay, so I'm going to call this 13.35, and like I said, you could see it a little bit differently. All right, this picture is pulled from a lab that I had students do, and this is a graduated cylinder. Okay, and so if you read a graduated cylinder, you have to adjust your eye level so that you are down at the water level, so your eyes and the water level are matching so that you can see straight across there, and you read the bottom of the meniscus, where the bottom of that kind of dips a little bit. Okay, so if I blow this one up, let's see if I can do that. All right, so now I want to look at this graduated cylinder. The first thing I see is, okay, I've got big points here from 25 to 30. Okay, so then I need to start thinking about, okay, what do these little tick marks here stand for? Okay, so let's see. If we go from 25 to 30, that means that this one must be 26, 27, 28, 29. So each of those tick marks counts for 1 milliliter. Okay, so this is a milliliter graduated cylinder. Let's mention that. Okay, and so 25 to 30, each of these tick marks counts for 1 milliliter. Okay, so I'm going to go up here and I see 26, 27, and then in between 27 and 28, okay, is where my meniscus falls. Okay, so it would be wrong if you put 25 point something or 26 point something or 28 point something or 29, because it is for sure that this mark falls between the 27 and the 28. Okay, so 26, 27, and the 28. Okay, your estimated digit is now determining how far you think it is between those two tick marks. Okay, so I put that I thought it was 27.6, that I thought it was a little over halfway between those two marks. Okay, you might put 27.5, 27.7. Okay, this last number, okay, so I'm going to pull it off of this. Okay, so I put 7.6 milliliters. Okay, this is the estimated digit. Okay, and so this is where some students get confused. Okay, if you were to read this graduated cylinder and just write 27, that's wrong. Okay, if you just wrote 28, that's definitely wrong. Okay, you have to estimate a digit whenever you are recording measurements. Okay, so you look for how it's calibrated. Figure that out first, because different instruments and different graduated cylinders even are different. Okay, and then from that point you find what you know for sure, where that object or where the water falls, and then you look in between the two calibration points and try to estimate a digit from there. Okay, so these are two examples of how to estimate digits. Hope you better understand this. And one last thing I do want to mention is when you use a balance, okay, in the lab, you do not have to estimate a digit on it. So it's going to record it already, including that estimated digit. So you use all of the numbers that you would get from reading from a balance. So that's why we didn't include mass in this video. All right, but I hope this helps, and have a good day, and I'll see you soon for the next part.